Okay, having our definitions of coterminal and reference angles put behind us, we're in a position now where we can set up the situation we need in order to be able to find our trigonometric function of any angle in the plane. So, what do we do first? Well, the first thing we need to do is we would want to put our angles in standard position. And when I say standard position, I actually say that if we're dealing with degrees, we want to have our angle between 0 and, I'll use the angle theta right here, 0 degrees and 360 degrees. Or if we're in radians, 0 and 2 pi radians. So that's where we want to find our standard position angle. We use that next to find our reference angle of the given angle, and we'll show that we can find the trigonometric function of the reference angle if we know what those basic right triangles are, and then we can decide what sine corresponds to that given angle. Now all of this seems kind of mysterious without a little bit of examples here. So let's start with principle number 1 here. First, we need to put the angle in standard position. What does that mean? Well, for example, we might be told, let's let the point -3,4 be a point somewhere on the terminal side of an angle in standard position, and find the values of the sine, cosine, and tangent of that angle. All right. So what I'm going to do is I'm going to draw a nice straight line right here from the origin through that point. All right. Now, I'm drawing it as a line segment, but we know that we've got a line that's passing through there. So the question would be, well, how do I set up my angle in standard position? When we say standard position, of course, we mean measured from the positive x-axis around the origin in rotation counterclockwise to get our angle theta. So we can set up a sine, cosine, and tangent about that? Absolutely. The way we're going to do it is that we're going to set up a right triangle over here in the second quadrant. Only this time our adjacent side can be negative. Depending on where we put our triangle, our adjacent or opposite sides could be positive or negative. But of course the hypotenuse is always positive, and we know that in this case this happens to be a 3, 4, 5 triangle for a Pythagorean triple, and so that is our hypotenuse. The hypotenuse is always given as a positive value. Okay, so given all that information, you'll notice that inside of this right triangle, there's a reference angle theta, theta prime. Well, it doesn't matter what the reference angle is in this case, since our sine, cosine, tangent, secant, cosecant, and cotangent were defined in terms of the ratios of sides of a acute right triangle. We're building an acute right triangle, only this time we're allowing the possibility of negative and positive signs, so that when we get our trigonometric functions, they will be of the acute angle theta prime, and the negative signs due to whatever quadrant we're in. In this case, we're in quadrant 2, so what we're going to find is the following. Sine of the angle theta is equal to the length of the opposite side, which is positive 4 over the hypotenuse, so that's 4/5. Cosine of the angle is the length of the adjacent side of the hypotenuse, only in this case the adjacent side is negative, so we would give our cosine of the angle theta as negative 3/5. And then finally the tangent of the angle theta is the ratio of the opposite side to the adjacent side, and we see that that's also negative 4/3. All right. So we can set up our sine, cosine, tangent, and by the way, cosecant, secant, and cotangent of that same angle theta using those same using these ratios of these sides. So we're pretty well set.